In today's lesson, we'll be learning how to find the equation of a line with slope and a point. As discussed previously, a linear relation is just a pattern, and this pattern can be represented with an equation. Both these equations mean exactly the same thing. We've learned that rate of change is the same thing as slope, and initial value is the same thing as y-intercept. Take a close look at this table of values. We've been given two pieces of important information. We know that figure 5 contains 19 blocks. We also know that the rate of change is an increase of 3 blocks for every one figure. We need to use this information to figure out how many blocks are in figure 0. In other words, I want to find the initial value. What you could do is use the rate of change to work backwards. I've gone ahead and done that already for you and found that figure 0 contains 4 blocks. In other words, the initial value is 4. I can now represent this table of values with an equation, y equals rate of change multiplied by x plus the initial value. We were already given the rate of change. It was an increase of 3 blocks for every one figure number. In other words, it was just 3. And we used this information to work backwards to find the initial value, which was 4. Therefore, this situation can be represented with the equation y equals 3x plus 4, where y represents the number of blocks, and x represents the figure number. Now, what happens if I give you a table of values like this? I've only given you two pieces of information. You know that figure number 100 contains 304 blocks. You also know that the rate of change is an increase of 3 blocks for every one figure number. We want to know how many blocks are in figure number 0. In other words, we want to know the initial value. We can start by using the rate of change to work backwards. If figure 100 contains 304 blocks, that means figure 99 must contain 301 blocks. But are we really going to count backwards all the way to figure 0? There must be a faster way, and there is. If you remember, we were given two pieces of important information. We were told that figure 100 contains 304 blocks. We were also told the rate of change. It is an increase of 3 blocks for every one figure number. In other words, we can just write 3 as the rate of change. Next, we can replace some of our variables with their known values. I'm going to replace y with the number 304. Next, I'm going to replace rate of change with the number 3. Afterwards, I'm going to replace the variable of x with the number 100. And this is going to look a little bit strange. It now looks like 3,100, but there's actually a multiplication sign hidden in between these numbers. The next thing you want to do is simplify 3 times 100, and we're going to do that below. The 304 stays the same. 3 times 100 is 300, and the initial value is going to stay put as well. At this point, you want to look for like terms. You'll notice that 304 and 300 are both like terms. Like terms like to be together. You can either move 304 to be with the 300, or you can move the 300 to be with the 304. I'm going to move the 300 to be with the 304. Remember, generally speaking, you want to keep numbers and variables on separate sides of the equation. When you move a term over the equal sign, it becomes the opposite. So it is no longer 300, it is now negative 300. And the initial value is going to stay the same on the other side. I've just removed the positive sign because you don't really need it. Next, we're going to take 304 and subtract 300, which gives us 4. Therefore, the initial value is 4. With this limited amount of information, we figured out that the initial value is 4. And we did that without having to count all the way backwards from figure 100 to figure 0. We already knew the rate of change, and that was 3. That was an increase of 3 blocks for every one figure. We also know that y in this situation represents the number of blocks, and that x represents the figure number.